When it comes to creating data manipulation, custom logic, interactive behaviors, and system automation, most of that happens inside the node editor. Utilizing a node-based programming, Grid Studio gives you a flexible, code-free way to connect data, manage triggers, and drive your application. Inside the node editor, you have access to two fundamental systems: the modifiers and the workflows. While both use nodes and wires to connect nodes together, they serve completely different purposes. The easiest way to understand the distinction between the two is how data and execution moves through them. Modifiers handle real-time data processing, while workflows handle event-driven logic. Taking a closer look at the modifier system, as you can see, data is continuously coming in, and as it goes through the different nodes, they get modified. Modifier recalculates on every single tick of the system, depending on the frame rate of your system. For example, in here, we're doing 30 FPS. Then this means all of this calculation is doing 30 times a second. The different colored lines represent different data type. For example, in here, we've got the position of the tracker, and this would have basically it's called a factor 3, or it has three values, the X, the Y, and the Z value. There are helper nodes to help you convert different data types. For example, here you have the factor to float, so that breaks it out from a factor into the three separate float values. And you can then modify them as you would like. You can right click, and you also get a list of different available nodes that help you to do any recalculation that you need, any smoothing, or any conversion of the different data type as well. Think of it as a live data stream. The data constantly flows in, gets transformed, and output instantly. This makes the modifier best suited for high-frequency, frame-by-frame data, like using live sensor data to directly manipulate other parts of the system. In this example, we can take a look. We have the position value of a tracker, which is coming in from here, and we're just doing some manipulations. And at the end, we're controlling the position of a separate tracker that you can see being visualized in here. You can simply drag and drop other nodes and parameters from the inspector and create new outputs, convert that into the proper signal type. And let's say I want to now have the X value, or the velocity of that tracker, to drive the X value of the end results of the tracker 2. So now you can see in this visualizer, instead of it previously only moving in a straight line, we have it moving in an elliptical shape, because now the X value of that is being driven by the velocity, or the X direction of the velocity of tracker 1. The workflow, on the other hand, is built for event-driven logic. Instead of running continuously on every frame, workflow sits idly until a very specific event has been triggered, meaning it happens asynchronously with no relationship to your project frame rate. When an event has been triggered, connection line turns green temporarily, indicating the signal flow of the workflow. Events can be many different things. It can come from a button press. In this example, when I'm pressing on this button, it generates an event for button press. It can come from internal logic objects. For example, this area object is targeting a tracker, and as the tracker is entering or leaving this object, it would generate an event. It could also come from external sources. So for example, if you're receiving an external message, where I have from a different machine, I'm receiving a OSC message. This message would be processed, and the OSC protocol would generate a on-message event. So this happens from external sources and whenever you're receiving a message. When an event has been triggered, the connection line carries data downstream from it and to the following nodes. When an event has been triggered, connection line carries data downstream to the following nodes and trigger the next appropriate action. Each node in the chain would actually inject new data into the chain, providing new information to the nodes downstream, and so that that node would have full visibility of everything that has happened before it. If we open up the data panel, we can see that happening. So if we now select the logic node that is at the end of this chain, we can see the last time that has been triggered, and these are the messages that it received on this OSC message at this address with this value. And because we have a get vector node that is going off and fetching new data, and thus ingesting that information into the signal chain, that's why this log node would actually have this information. So we now go and trigger that by sending another message. You can see that has been updated with a new value of the time and what that value is, and the vector value of that get vector node. And then you can then just directly drag and drop from these information here into, for example, this log node. Let's say I want the value from the OSC message, and now that will be logging that value into the log window. This can then also be combined with different things, and you can do quite complex logic from here. It is also quite easy to start creating your own events and do the appropriate things. For example, you can select an object and directly drag from it into the workflow and let go, and you'll be able to select which type of event that you're interested in. For example, let's choose on playback starts. So this object, the VLC, would have a playback start event, and I'm able to be informed when a video is started. Alternatively, from the inspector, you can also get that list, and you can then also directly drag from here a specific action or event as well. So as an example, we can then say we would want to adjust the volume of that VLC player. Whenever playback starts, I want to make sure the volume is set to 100. So this is how quickly you can create logic from and triggers things depending on the different objects that you have on your project tree. Some objects actually comes with their own default workflow. So if you unlock the node editor, which, by the way, the node editor comes by default in an unlock mode, and as you're clicking around into different objects, you would see the appropriate workflow or modifier that's associated with it. In this example here with the Pixera objects, you can see there is a timer that will go off and check the connection and make sure that we have a decent connection with the Pixera system. And then whenever that connection state changes to connected, we would go off and fetch a bunch of information. For example, timelines, queues, layers, and so on. And then also there's another timer, which is on every minute, we actually go and try to do this as well. So this is the way that we, by default, ship some default behaviors for some specific objects. And if you click onto it, you are feel free to go off and actually start editing that if that's not what you like. For example, you don't like to check the connection so quickly, you're comfortable and you don't want to spam your network with extra checked information, you can come in and just adjust. So I don't want to check every 10 seconds. I want to say I want to check every 30 seconds as an example. Let's look at another example of a workflow. Here we have a button that will trigger this workflow. And the idea of this workflow is that it will go and attempt to power on a projector. It will wait for a few seconds, and then it will go off and fetch what the current power state is. It will then do a comparison and say, hey, if the projector is turned on already, then it will go off and give you a little notification saying that the power on command has been sent and now the projector is on. But if the condition has failed, it will go and repeat and re-attempt to turn on the power again. And after so many tries of the repeats, it will then say, hey, we've tried a few times, it's not working, something's wrong with the projector. So if we click on this button here, you can see that gets triggered. It waits for a little while, goes off and fetch, and it say, hey, it did not work, we're going to retry again. And it's going to keep trying until, let's say here, we've got a little temporarily override and say, hey, the power is now on. And then you see this chain or the signal path has switched over and we got the notification saying that, hey, the power is now turned on. So this is a nice little demonstration of how you can create logic and using some of these internal nodes that we provide, for example, a wait and a condition node, they can start creating your automation and logic based on what you need. Let's quickly look at another example of workflow. Here we have a action where you can go off and fetch a REST call and get some data from a REST server. And what happens is that once that data is received, this node would actually take that response and actually save it inside an object and then creates the appropriate entity or additional information that is needed. And it will then go off and update this text here and says that, hey, we've gone and updated this drop-down menu. So when we click on that, you can see that gets updated. And because it's been populated already, but in the end, it does repopulate this drop-down menu. On the bottom here, we have a different workflow where the drop-down menu, when the drop-down menu has been selected to something else, it will go off and go into the entity or the data tree of an object and actually look for some value. If it looks for a value and that value actually exists, it would actually get that value, which is specifically the color of a specific object, and actually then send that information as a OSC string to someone else. If the value does not exist, because if we can look at the response from the REST call, you can see that some objects actually does not have a color associated with the device. So if we scroll down, further down, some objects don't actually have a color. You can see it actually doesn't even have that value in the tree at all. So when we're selecting different objects, you can see that sometimes it will change to brown. And otherwise, if it doesn't exist, we will reset it or set it to just a dash, at least saying that, hey, that object does not actually have a color. So this is how you would actually be manipulating more complex data structure inside a workflow. So in summary, we have a real-time data processing system called Modifier, where it takes data on every single tick of the system, modifying its values and sending it back out to something else. And we have an event-driven logic system called Workflow, where an event is triggered from different locations and places, grabbing extra data that you need, combining that data together from different sources, processing that, and even adding conditions to then decide what you want to do on different branches and creating the necessary automation that you need.